Question 9. An airplane is going in for a landing at a nearby airport. Its angle of depression to the runway is 2.9 degrees and its elevation above the ground is 2464 feet. Assuming the ground is flat and the angle of depression remains the same, what is the distance from the nose of the airplane to the runway in feet? Okay. So remember, we're always talking about right triangles. That's this whole section. So always start by drawing a right triangle. And we have an airplane coming in for landing. So here's our airplane. There's some wings. I'm not an artist, you guys. All right. So here's our airplane. It's coming down at an angle of depression. So remember, 2.9 degrees, it's coming down, and that also goes here to a runway. So I'm going to change color here. Right here is going to be a runway, and that's what it's trying to hit. And then the airport would be over there, right? So let's see. The elevation above the ground is 2464. So here's our airplane. If we go down to the ground, it's 2464 feet. Okay, the ground is flat. Our angle stays the same, so it's going to not change angles as it flies in. What's the distance from the nose of the airplane to the runway? So here's our nose of our airplane. It's asking how far is this line down to the runway in feet. So no conversion here. All right, we're mixing it up. Here's our angle. We know the opposite, and we're not trying to find the adjacent this time. We're trying to find the hypotenuse. So which trig function, sine, cosine, tangent, has opposite and hypotenuse? Sine. Sine of our angle, opposite over hypotenuse. Now let's solve. So multiply by the denominator. And then divide both sides by sine of 2.9. So that's going to give us our distance. So 2464 divided by sine of 2.9 degrees. I'm just going to make sure I'm in degrees. And it says round to one decimal place. So 48702.4.